Bismillah. Any question from anyone? If not, I will just. I think this is. I think in the last class we have the quiz number 7, if I'm not mistaken. So I will just go about this quiz in case anyone need any explanation on this with regard to couple moment, right? A moment of a couple.
Oh,
Okay. Yes.
Doctor, I had a question actually about
Okay.
the concept quiz.
About what?
Concept quiz, Doctor.
Concept quiz of the lecture
That
slide.
lecture, yes. Yes.
Which one?
Question two.
Consider two couples. That is that one. The one.
Yes, yes, Doctor.
Consider two couples acting on a body. Wait. This one?
Yeah,
Consider
Doctor, correct.
consider two couples acting on a body. The simplest possible equivalent system at any arbitrary point on the body will have which one? Oh, so you are not sure which one?
I mean, my answer is one couple moment, but I'm not sure if it's right in this case. Yeah.
Okay. Yeah, of course, because this actually test more on the understanding on couple, right? What makes a couple, as well as then the meaning combined with the equivalent system. So if you have two couples, obviously the resultant force will be zero, right? For any couple, resultant force will be zero. So the simplest one will obviously be one couple moment. Is that was your answer, right?
Yeah, that's my answer. Yeah.
Yeah, that is correct.
Check it. That's all okay. All right, because the couples itself, they cancel out each other, right? If you consider them linearly.
Correct.
Okay. All right. Thank you, Doctor.
Okay, welcome. Any other question? Of course, after this, you can still ask question, but I will just go about this one for a few minutes, I think, in case anyone would need the explanation. And just because I think the recordings will be made available in the playlist, so anyone who would need to refer to this in preparation for the midterm as well. Okay, so in the previous quiz that you have done about couple moment, we have 2D and 3D question. So in the first question for 2D, based on the diagram here given, determine the resultant couple moment acting on the beam and then state the direction of rotation of the moment, right? So in any question like this, it's easier to be solved if we first resolve the forces into the component of horizontal and vertical, right? Because in that case, the distance will be straightforward. So in this case, you will have, um, you will have this one and this one as the vertical and horizontal. So this will be 500 3/5, meaning it will be 300 Newton. This will be 500 4/5, which will give you 400 Newton, right? So the same goes here. Oops. So that's horizontal and vertical basically. So you'll get 300 Newton and 400 Newton. Now, after this, then everything should be quite straightforward and simple because we just pair the two same magnitude and opposing direction forces as a couple. So one, if you take the vertical one, so it will be basically like this for the 400 Newton pair, and the distance will just simply become straightforward, right? This is 3 meter. And we have another one, which is the horizontal forces. It will be something like this with a distance of 1 plus 1, 2 meter, right, of 300 Newton. Now, from here, it should be clear enough what is the direction of each couple. So this one will produce this one counterclockwise, while this one produce clockwise rotation, right? So when we want to calculate what is the resultant couple moment, so if you do summation of moment, couple moment, if I take counterclockwise as positive, for example, so in this case, this will become positive 400 times 3 meter, and then this will become negative because this is clockwise, so negative 300 times 2 meter. So in this case, it will be what? This is 1200 minus 600, right? So basically, if the calculation is correct, you get 600 Newton meter. So because it's positive and we assume positive to the counterclockwise, so it means the direction is counterclockwise with this value, right? So that already answered the magnitude as well as the direction. So this is the magnitude 600 Newton meter. The direction is counterclockwise, right? So if you just indicate the direction like this, it is sufficient. If you use CCW counterclockwise, also it is sufficient as well. Right, so that is just the straightforward question for the 2D. And of course, you can see the mark indicate that it should be straightforward there. Now, next, I will just go to the 3D question here. Oops, down here, right? Okay. So for this 3D question, the concept is still the same. It's just that we will use the vector operation. So based on the diagram below, determine the magnitude and coordinate direction angles of the couple moment. So first, you have to understand if you are facing question like this, what is the final answer look like, right? So in this case, we need the magnitude. So what is the magnitude, right? So of course, when you do vector operation, we normally will get the vector first, right? So how to get this one is just square root of those things, right? So we know what we need to do here. And then we need to have alpha, beta, and gamma, right? So if we already have the magnitude and as well as the x component, y component, z component here, so this is just cos -1, the x component divided by the magnitude overall, right? So we know what to do. So to get this vector is just that moment of a couple equal to R cross F, right? So in this case, it's just as long as you understand the concept, what this R, this is from one force to another, and we have two options here, right? Either R A to B here. So if I use R A B, that's one option. Another option is the opposite way, right? So RBA. And hopefully by now you already understand the concept. If you use RAB, the force should be this one, right? So R is in this direction and then cross B here. So it will be crossing with FB. While if you are doing the opposite way, RBA, F will be this one, right? So it will cross F A. Either one of these will give you the same answer, right? But if you mix up this one, then conceptually you get it wrong, and of course the answer will also be wrong. Make sure you understand this concept. It's just similar if you understand moment about a point. For example, point here, the force will be here. It should be straightforward, I think, right? So if you have done this, so just get the value here for R, and F is already given. Normally in the final exam or in the midterm, you rarely get this given like this. Quite rarely, I think, but for the quiz, we want the calculation to be, we just want to test this one. So this one is given straight away so that the time is sufficient, right? But in the exam, if the time is longer, even this one, the question might, you need to do the coordinate, etc., right? So it will be a longer question then. Right, but the concept is if you understand the concept, inshallah, everything is manageable. And then after you have done this, you get the vector, just get the magnitude by the square root, and then hopefully you know already by now what to do with alpha, beta, and gamma. right? So this is just the same as when you do for resultant force as well, right? So what you do, x component over the magnitude overall, y component over the magnitude, etc. So that is how you solve for this question in the previous quiz. Right, so if there is any question with regard to this chapter or any chapter in preparing for your midterm or for today's chapter, which is about simplification, of course, feel free to ask. So I'll finish this one first. All right.
Assalamualaikum, sir.
Waalaikumsalam.
I want to ask about the slides. So 4.7 and 4.8 on page 13.
Page 13. That the brown slab there, the brown plate there. Is that the one? Example 2.
Yes.
Okay.
How to find the value of x and y, and the last question.
How to
X and y.
Okay. Wait, for this one, meaning you do not understand, or meaning in the lecture, is it explained?
I don't know how you get the negative values for x and y.
Oh,
How?
meaning that you want to understand why that negative. Okay, I forgot already. When I do the solution in the recording, is it by using scalar or vector?
I think you use vector maybe.
Maybe because in term of, because you can solve by using both way, but if you use vector, then the negative will come automatically. If you use scalar, then you have to understand whether it's clockwise or counterclockwise. So for your case right now, which way do you want to do it?
Oh, I can use scalar or vector.
Yes, both will give those the same answer. Yeah. So which one? Because which one should I explain?
Okay. If I use like on the slide, how can
On
we?
the slide, I think they because in the slide it just use scalar, meaning suddenly you get some like negative MRYO divide by FR. That's in the slide, right? So based on the slide, you have to understand where that came from, lah. Because that is not really it's not an equation.
Oh,
You cannot memorize that because that only valid for this question, because when they change the location or whatever, it will change, because that negative and for y that's positive is because of clockwise or counterclockwise. So you have to understand that. So you cannot blindly follow those. If you want to use scalar, you really have to understand the concept, what is going on. Otherwise, you will make mistake, because if you use vector, when you do the cross, then positive and negative is just it will come out automatically, right? When you do when you close, then this minus this minus this one. So what will come out, positive or negative, it will automatically come out. But of course, the how to say, if you want to use that one, it will be a bit longer in the on paper lah.
thank you.
So do you understand?
Thank you,
Okay,
sir.
okay, faham ke ni ke? You want to try first, or do you understand what's going on?
If I have problem, I ask you again.
Okay, okay.
Okay.
Uh, so how I want I didn't understand about this phrase. And specify where this line intersects member AB measure from AD.
Apa dah? Come again. Specify the location. Is the part that you are not clear of?
Yeah. Yes, sir.
Okay. Let me. Okay, because it seems quite small.
Yeah.
Okay, but the steps before you are clear, meaning that until, because you have to replace by part A settle, is it?
Settle, sir.
Okay, part B then you replace by a single force and then specify where the location is.
Yes.
So that is where we want to know. That is the further simplification. So
Settle.
the question already state that when you further simplify, the question want to know where the force is. What is it? Line AB. So the vertical apa nama kita? The vertical palang tu. The vertical palang tu A to B. So the where will the FR cross that beam tu, the beam AB? What position? Measured from A, meaning that the D is from A upwards, something like that. So what is the distance D?
You mean that the distance from point A, sir?
Yes,
Sir.
from point A, because when it says measured from A, meaning that the if you redraw it with a distance D and that FR is somewhere along that line, where is that D? What is the length of that D, distance D? So that is what the meaning of the question.
Okay. So I must find the resultant moment first at point A.
Yes, but that one you already calculate in part A, right?
Yes.
So you just use that moment, because if you have done part A, actually you already calculate the couple moment at A, right? About point A. So you just use that moment to calculate the distance because you already have the resultant force, and also you know already the moment about point A. So where should that force be if to give the same moment?
And so why we must find the angle? The angle.
Why? What do you mean why? For the resultant force?
Resultant force. To find the distance, sir. Ke sana.
Well, okay. If you use FR in a scalar, you need to use theta to get, because when you want to calculate moment about point A, if the force is is acting on the beam AB, then obviously you want the horizontal component only, because that will F times D, the F will be the horizontal one, right? To get the perpendicular D. You can use that one. But of course, in part A, we when we say resultant force without angle is not complete, because it have to have the magnitude and also direction. So in 2D, you do have to specify the theta. Otherwise, it can point out any random way, which is not meaning that that answer is not complete. So when it's just like in chapter 2, when you calculate resultant, you always have to state what is the theta, because otherwise then the answer is not complete.
Okay. Thank you, sir. Thank you.
Okay.